Hello everyone, I'm Shrishti Deshmukh from MIT Academy of Engineering. Today I'm going to explain what is bridge engineering. This PPT will include what bridge engineering actually means, like its introduction, then its classification and components, then what economical span or some terms related to bridges will be explained here. Then how the loads, what loads are there on bridges, then what are the IRC load specification, all these things will be considered and will be explained in this PPT today. So moving forward on introduction to what bridge engineering actually means. So firstly, bridges are a vital infrastructure that connect communities and enable a smooth transportation to people, to customers. And in India, there are a number of bridges of different sizes, of different shapes, from simple beam bridges to the suspension bridges, as we all know about that. Then classification of bridges and its components. So here, bridges are classified by three types. First one based on function, then based on material, and then based on structure. So based on function, road bridges, railway bridges, pedestrian bridges are some examples, like what actually is the function of that bridge. Then based on material is like precast bridge or concrete bridge or steel bridge or suspension bridge. These are based on material. And then based on structure, like if it's a beam bridge, arc bridge, truss bridge or suspension bridge, based on structure these are. Then moving on the key components of the bridge. So there are various key components or the components of bridge. We'll go one by one. First one is deck. Deck means the surface of bridge on which the traffic moves. Then girders or beams are the supports, horizontal supports that are provided to that bridge. Then abutments and piers are nothing but the vertical supports, but the last two supports are abutments, end supports, and the middle supports of the spans are piers. Bearings are nothing but they allow controlled movement of a bridge, like expansion, rotation, etc. They are provided between the deck, like below the deck and above the piers or abutments. Then foundations, the basic principle of foundation, that is to transfer the load safely to the ground. Then moving on some technical term, like what economical span, afflux, HFL, and scow depth means with respect to bridges. So economical span actually is the span length, that is distance between two supports, where the combined cost of the superstructure, that is deck and beam included, and the substructure includes piers and foundation, is minimized. That is nothing but an economical span. Then moving on the afflux, what afflux actually means. So afflux is nothing but rising water level due due to the bridge obstruction on upstream side. And HFL means high flood level, the maximum water level which was recorded during a flood used for setting the bridge clearance. Then scow depth. Scow depth is nothing but the depth at which water flows and that erodes the soil beneath or around the foundation. So this cow depth is estimated using the Lacey's theory, and it can be prevented by protective works like riprap or sheet pillings we can do to prevent cow depth. Here's its loads on bridge, and overview about the loads on bridge, what kind of loads are there on a bridge. So there are various kind of load, like dead load, live load, and environmental load. Environmental load mainly includes like wind load or seismic load or water pressure load or temperature changes loads. Dead load means what weight of the, like self weight of that bridge only, which includes fixtures, then utilities, etc. That includes dead load. Live load is nothing but the movable or dynamic load, like vehicles, pedestrian, trains, etc. Whatever the movable load on that deck is, that's live load. And environmental load, as I said earlier, loads due to wind, like wind load, earthquake, that is seismic load, temperature changes, that is thermal expansion and contraction, then water load. These all are included in environmental loads, even snow load as well. Moving forward on IRC load specification. So there are some specification given by IRC. IRC means Indian Road Congress, to categorize the load. The first load classes are like class AA, which includes heaviest load for the important bridges and highways. Then class A, which include normal and medial road traffic, and then class B, which include lightweight road, like light traffic, which are pedestrian or temporary bridges. Then load combinations. So, while designing a bridge, we consider combined effect of multiple loads on which we apply safety of factor to ensure the reliability under various conditions. The bridge should not fail in varying conditions. Or so load combinations are applied. Various load combinations are applied. Then example calculations. This is nothing but includes the calculation of vehicle load or dynamic load, how loads are distributed to different part of bridge. This all these things are included in example calculation. Then moving forward on the case studies of failure of bridges in India. So generally, like these days, a lot of bridge fails. So then firstly, we will go by this PPT. Failure causes. First one is design flaws. Bridge collapsed in Bihar in 2023 and its frequency was about 35%. Then due to scour and erosion, bridges on various rivers nationwide fails due to the scour and erosion and its frequency is 30%. Then also due to poor material used while construction, multiple incidents happen due to this in India and its frequency is 25%. And overloading and maintenance is also one reason of failure of bridge and its frequency is 10%. And this is like very common in urban areas. Now, what prevention we can apply or we can adopt for for this failure and rehabilitation of techniques. Then first one is inspection. Regular inspection or routine visual check should be done. Non-destructive testing should be done to identify the early damage so as to do the early preventive measures. Then strengthening techniques can be carried out like jacketing. Jacketing means applying a layer around old components. Jacketing can be done. Then overlaying can be done. Overlaying is nothing but adding a new material to an existing material to improve or to increase its strength. And even post tensioning can also be done. Post tensioning is nothing but reinforcing with tension steel cables. This is a new technique, post and pre-tensioning. Then bridge management systems like structured maintenance plans and timely repairs to extend service life of that particular bridge. All this can be adopted. Lastly, the conclusion, that is the future of bridge engineering. So, first one is sustainability, like use of more eco-friendly materials and design bridges which will minimally impact the environment. Then advanced material, use of composites or high performance concrete and high sensors for better performance and monitoring of bridges. Then safety and resilience. Safety and resilience means which emphasizes on building bridges durable enough to withstand any type of climate change or any extreme natural event or anything out there. So this is nothing but safety and resilience. Bridge should be constructed in such a way that it should be able to withstand any pressure, any temperature change, or any weather change, or any load out there. It should not fail. It should have more lifespan. So, thank you. That's all about the presentation. Thank you so much.